Hey everyone, it's Mike from Cymulate, and today we are going to take a look at the lateral movement vector in the Cymulate breach and attack simulation platform. Lateral movement is the idea of starting with one Cymulate agent that's simulating an initial compromise, and then seeing how far a micro agent, a miniaturized version of that agent, can be propagated within a network. And to do so, of course, you'll have to have a Cymulate agent deployed to presumably a Windows desktop or server. And then, as with our other vectors, you can pick from one of the pre-built templates, but it is not uncommon for customers to create a custom template for lateral movement just due to the nature of this particular module. And to do so, you're going to state which methods will be permitted to spread, to move from one machine to another. You could select as many as you want, up to and including all of these choices. And what methods will be acceptable to attack, to gather credentials and tokens and hashes as the system goes. You can also set a scope which can limit the ability of the assessment to move within a particular network. Scope ranges define what is allowed. Exclude ranges define what is out of bounds. You could also decide to have it attempt to reach just one device and no other devices. There are some additional miscellaneous settings that allow you to change aggressiveness or speed or define different subnets. We could even check for the eternal blue vulnerability as we go through the environment in question. By default, the system will attempt to evade discovery by using encrypted communication. And last but certainly not least, you can define crown jewels. Now, crown jewels are not required, but what they are is devices, networks, groups, or users, which, if captured, should score more heavily against the overall scoring for the assessment as a whole. So if there are particularly important servers or particularly important networks, like if you're starting in a production network and you want to see if it can reach an internal network, a private or privileged network, then you can define them as crown jewels, and that will not only have them show up in red when we map everything out, and you'll see that in just a moment, but also have them count more heavily when we are producing the Cymulate score for the overall assessment. So once you've decided on these particular settings, that of course becomes a template, and the template can then be selected. You'll define which agent will be used as the initial compromise. And you'll note that you do have one additional option here. That is whether or not to allow the lateral movement data to be uploaded to the Cymulate cloud. Now, under normal circumstances, data uploaded to the Cymulate cloud is considered non-privileged by most regulatory or company policies because it does not contain any personally identifiable info or personal health info or business confidential info. It's just, did a particular scenario complete or not? Was a file successfully written to disk or not? But in lateral movement, we are purposely attempting to capture tokens and credentials and hashes, and that of course can be considered privileged info. So we give you the choice of sending that data to the cloud. Cymulate is SOC 2 Type 2 certified, so it will be very well taken care of, or keeping it local to the device that is running the agent, the device simulating the initial compromise. If you choose to keep it local, you could still send trace information. The trace, for those who haven't seen it before, is the line-by-line readout of what activities are occurring. It does not contain any of the actual tokens or users or hashes, except for some minor things like user names, but never passwords and no tokens, no hashes, none of that kind of thing. But it allows you to see the progress of the assessment before it is completed. So you can choose one of three options. Upload nothing. All of the data will be kept either on the device that's acting as the initial compromise that's running the Cymulate agent, or in a UNC network path of your choice. Option 2, upload everything to the Cymulate cloud, where it will be quite well cared for and protected. Option 3, do not upload any main data from the assessment and the simulation components, but do allow trace data, meaning what activities are going on, not necessarily the outcome of those activities. So you could choose from any of those three options. And then, as with all of our other vectors, you could say whether this will be a one-time simulation event, perhaps the spot check after you've made some changes within a network, or whether this is a recurring daily, weekly, or monthly automated assessment for ongoing assurance while you're getting updates on a regular basis so that you can see if anything is changing along the way. You would then hit launch and the system will take it from there. And what it is going to do is the agent will take a component of the agent platform, informally nicknamed a hopper because it jumps from one machine to another, and it will attempt to launch that hopper as a service on any machines that can be seen by that initial device. When that is performed, if it successfully makes a jump to another device, then the process repeats. We pivot to that device and begin the process again from that device. And then all hoppers and the original agent can share information with each other to further the propagation throughout the network. Now, this process can take a significant amount of time, especially if there are a lot of credentials that need to be gone through and have been discovered. If there is a particularly large network segment with a lot of discovered devices. So unlike our others, which are usually in the scale of 4 to 12 hours from start to finish, usually closer to the lower end of that scale, lateral movement is really a wild card in terms of how long it will take to complete. It's going to be very different depending on the network and the security controls in place. So it may take some time to run through, but once you have run through and it completes, then you will be able to generate a report, either by opening a zip file located on the device running the Cymulate agent or in the UNC path of your choice, and then loading an HTML page from that zip file in your browser, in which case what we're about to see will be loaded locally, or by, if you have decided to upload to the Cymulate cloud, coming to the reporting area as I've just done, and then selecting the assessment that you would like to review, and then selecting technical report. Now, in either case, what happens next is the same. It simply is a matter of, is this data being pulled from the Cymulate cloud and then parsed locally, or is it 100% locally parsed in your environment? That's the only difference. And you can see that it's now building out a report of what occurred during this simulation. And we have three main components: an information panel on the left, the summary on the right, and we'll look at that in a couple of moments. And then the main part of the screen is the map of what occurred during the simulation. This white circle here on the left-hand side, and I'll just move that over here so it's a little easier to see, this is the initial compromise agent. It's the agent that was purposely installed, simulating that initial foothold. Every other circle on this map indicates a device that we successfully launched the Cymulate hopper on, the micro agent on. And as you can see, in some cases it's not a direct initial access to target. It may have to go through intervening servers. They're also color-coded with three different colors. Blue indicates devices that don't appear to have any shared services: file shares, SQL Server, web services, etc. Amber indicates that there is the presence of some form of shared service. And red indicate crown jewels. And in this case, the crown jewels we selected in this environment were domain controllers. And if I were to select one of them, such as this one here, in the middle at the lower end of the scale, there we go, you could see that the system has lit up the path that was taken. Red is the initial jump. Yellow indicates subsequent jumps where they are required to get to wherever I'm going. And in this case, we took a path that jumped through quite a few different servers or desktops. So when this does jump through many different hoops, it can be quite difficult to figure out exactly the path that was taken. This is also true if you wanted to see how we were able to move from device to device. And so to clarify any of those two things, either the path that was taken or the attack methodologies that were used, or both, you could just go to this call to action button at the bottom of the screen. Tapping that will bring us to a page that shows just the route from the initial device all the way through whatever device we selected. And we could see that at each hop from one machine to another, the system is showing me the TAC method that was used, in this case, access token manipulation. And of course, if that's clicked on, it's going to give you a description of the method and potential options for mitigation. And again, we'll give you as many of these as possible, as we do in our other simulations. And the spread method. So in this case, the spread was over SMB. And again, the description of the particular methodology and steps that could be used to mitigate against this methodology. In this particular environment, there was a vulnerability in the SMB platform that was not patched, and so we were able to use that to propagate quite far. In addition, at each hop, we will show what information was collected. And so we saw 6 services that were running. So this does appear to be a database server that is running a website, because we have both a web service running and several different SQL services running. We were able to obtain 4 different hashes for these 4 users. And we were able to grab 1 token. Now that becomes important because if you remember, access token manipulation was the method used to make the next jump. And so a token is going to be very valuable information. We allow you to see that here. And we'll do this for each subsequent jump that's taken. So 3 tokens and 2 shares and only 1 service on this one, but 7 different hashes. So we did get quite a few more hashes here. You can always go back with the blue button, and that'll bring us back to the map page. And we could select another device and do the same thing and see how we got there. Go to the call to action to see what information was obtained at each hop, what methods were used to successfully jump from one server to another, etc. Now, in addition to the map portion of this view, you can see on the left-hand side that we have overall information. And so we know that we were able to propagate to 68 different servers and 83 different workstations. Clicking any of these will bring up a panel so that we could see which ones were involved in this and their IP addresses. We were also able to gain close to 700 credentials. Now, these are both hashes, as we see for the majority of this listing here. But if I scroll down, we are going to get into some of the passwords that were also captured. If I go down to close to the bottom here, the majority of what we caught was indeed hashes, which is still not a great thing, but something that would have to be manipulated in order to use it. But if we do scroll down quite a bit, we start seeing that certain passwords were obtainable through reading them out of memory where they were stored as clear text. And you will notice one other thing. Only the first 3 characters of a password or a hash are ever committed to the report. That is a safety procedure so that you're not permanently committing a record of actual passwords and hashes, which is good to know for compliance reasons. And again, if we click on any one of these particular methods, it will describe that methodology, and it will offer methods for mitigation. And in this case, there are 5 different ways that it could mitigate this, mostly involving native tools within, in this case, a Windows environment. And so this doesn't even require a third-party tool to stop this from happening. In addition, you'll notice as I've been pulling up these windows, there are these download buttons. Because this data does not officially go through the reporting engine, there are no PDF versions of this information as we have in the majority of our vectors, but you can download a CSV of any component data or of an entire timeline of events. So you definitely have offline reporting options available to you, just not the ones that you may be familiar with in other Cymulate vectors. All right, and of course, there will be a Cymulate score, which is weighing the results of this assessment against our usual factors, which are NIST 830 and CVSS3 and Microsoft Dread and the MITRE attack framework. But in lateral movement, we add a 4th factor, and that is the crown jewels. crown jewels, if compromised, will have more weight than any other device that has been compromised. So there is a bit more involved in generating the Cymulate score when we're talking about lateral movement, but otherwise it acts very much the same, and that Cymulate score will range from 1 to 100, with higher scores indicating higher levels of risk. And to be clear, when I say compromise, the system that we use for lateral movement is still non-disruptive and non-destructive. It won't take anything offline. It won't risk any user or organizational data or applications. So we're simulating that compromise as we launch that service that is under the control of the Cymulate agent on machine after machine. If it had been an actual threat actor, they would have gained control of that machine, and it would have been a true compromise. But in our case, those micro agents, those hoppers, distribute themselves where possible. And when the test is ended or stopped, then the system will dissolve those agents as well. So we're not leaving stuff behind all over the place. All right. So that is a brief overview of the lateral movement vector, from setting up a template to choosing where the information will be stored, which is a methodology unique to lateral movement, to launching and then reviewing the results. There is one other thing, and that is in the case of integration with a vulnerability scanner like a Tenable or a Qualys or an Insight VM. The system, if it uses a known exploit to propagate, can request a list from that vulnerability management system of any other devices within the network that have that vulnerability. Very similar to what is done in immediate threats intelligence. And so in our case, had we been integrated with one, we would have been able to see that the SMB flaw, the SMB vulnerability, was available in the majority of the devices within our particular network. So if you do have any questions, or you would like to see this in action or do a proof of concept of this, we do encourage you to go ahead and speak with your Cymulate sales team, and they'll be able to get you all the information you need on lateral movement or any other vector within the Cymulate system. Thanks for joining us today.